Hello everyone. I'm Takesako from Azbil Corporation, Japan. And then, I'm very sorry to say that I cannot speak Korean language, so today I'd like to make my presentation in English. Okay. First of all, I really appreciate Azbil Corporation. We, Azbil Corporation, became a member of SAREC. And then from now on, I would like to make much effort to share the valuable information with the SAREC, together with to get information from SAREC members, the valuable information to make the world more greener. This is the objective. Okay, so let me start my presentation. Okay, we Azbil Corporation. Okay, let me briefly introduce my company first, just a little bit. Group profile. Okay, we established very long time ago, and then our company have a more than 100 years history. And then our company name is Azbil, A-Z-B-I-L. And then you can easily imagine what our company is providing from this name. From this name, Azbil stands for Automation Zone Builder. Automation Zone Builder, then Azbil. Meaning that our company is providing the automatic control solution. Of course, we are the manufacturer, so we are manufacturing the automatic control devices. But not only the automatic control devices manufacturing, but also we are trying to provide the entire solution to optimize the entire systems. This is what we are now providing to our customers. Okay, and then in Japan, we are a Japanese company, so in Japan we have a more than 84% market share in HVAC automatic control market. So meaning that, actually I'm talking only this one is building, mainly the building market. So meaning that in you can easily imagine that you can in Tokyo area there are many high-rise buildings, but most of them we provide our own product and services to those buildings, more than 84% market share. And then this is just corporate profile. This is our company have three big business segments, which is building automation, and then advanced automation and life automation. Three business segments. And I belong to the building automation. So today I'd like to explain the building automation mainly. Okay, for the building automation, there are necessary devices such as control valve, BMS, sensors, controllers. We are manufacturing all of devices. And then we also have a global network, okay, like this. And then next is today's main topic, our smart solution and products. At first, I'd like to say that building energy management systems, which usually we call BEMS, maybe in Korea also the same BEMS, building energy management systems. Okay, so recently the building have to reduce the energy as much as possible. And then to achieve the target, we better to implement this BEMS to each buildings. Okay, building energy management system. Okay, this is just example. If you lose or if you reduce your weight, how you can do that? At first, have to measure your weight first. Otherwise, very difficult to reduce your weight. So BEMS is almost same as what this is doing. So visualize first, and then to analyze it, and then to focus the most effective portion to reduce the energies, and then we can step forward. Then basic system architecture of the BEMS is like this. Okay, BMS is a normal building management system which some of the building has already implemented. And then BEMS can be on top of the existing BEMS. Just to put the BEMS on top of the existing BEMS, and then we can easily establish the building energy management systems. Okay, so the BEMS have to get the data from the BMS or some other subsystems to collect the data and to store the data to analyze the data. That is the objective of this BEMS. Okay, this is the BEMS. So we are also manufacturing the BEMS. And then anyway, most important information is to achieve the energy saving, to visualize the energy consumption is the first step we have to take. The next from here is our advanced energy saving applications. Actually, those are our today's main topic. BEMS is just a visualization of the energy consumption. But before that, we have to take some actions to reduce energies or improve the energy efficiencies of the buildings. So this is the one. Okay, I'm from the building automation business section. So our major target to reduce energy is HVAC facilities of the building. Not only the building, factory also same. Factory, building, shopping mall, or data centers, hospital, everything is the same. So this is just a rough image of the entire HVAC facilities. And then in each HVAC facilities, we have energy saving applications. From here, at first I would like to talk about chiller plant energy saving application. There are 3 steps here. You can see first is the basic chiller plant control. Second is advanced energy saving application. Then third one is a digital twin. See, these 3 steps I'd like to introduce. The first one is a basic chiller plant control, which is the very, very basic one. Our company is providing an automatic control solution. So we also providing those applications, which is very, very standard chiller plant control. Sorry, again, let me talk only one thing. Okay, some of our customer also sometimes misunderstand that we are manufacturing. We are the HVAC manufacturer, like air conditioner manufacturer. We are not manufacturing the HVAC facilities. We are just providing the automatic control devices, controller, or servers, or sensors, or control valve. We are not manufacturing the air conditioner. Okay, maybe LG is manufacturing the air conditioner. We are not the HVAC facility manufacturer. We are manufacturing the automatic control devices. Okay, again, back to the topic. This is just a standard control method. We are calling this staging control of the chillers. Staging control. Staging control meaning that to determine the necessary number of chillers according to the load demand. Very, very simple. To measure the load demand of the building and to determine the necessary number of operating chillers. Very simple. This is very standard control. Okay. So once the load is fluctuating, according to the load fluctuation, we determine the necessary number of chillers and to turn on the chillers automatically. Of course, in case the load decrease, then according to the load decreasing, and then we determine the necessary number of chillers and we stop the unnecessary chillers also. It's all automatic control. Okay, so this is one very basic one. Then rotation control, sequential control is also one of very simple control method. And then in case the chiller, there are different capacity chillers is in combination. We also have to consider how we can put the priority to each chillers. So this is also one of the programmable method, how we can maximize the energy efficiency of the chillers according to the load demand. Okay, so the next one is This is also very simple. Daytime and nighttime, the load trend is totally different. Characteristic of the load trend is totally different. So the weekday, the daytime and nighttime, the priority of the chiller can be changed accordingly. So as a result, we can minimize the energy loss of the not appropriate chiller capacity. Most of the chiller have a characteristic which is a partial load can be the very, very low efficiency. So to avoid this thing happen, we have to choose the most appropriate capacity chillers. So that is also one of the very, very simple control. This is a nighttime mode. Change the smaller one to be the best chiller. In the nighttime, we can minimize the energy losses. Also, this is also one of the very simple control, which is VSD pump. VSD stands for variable speed drive, which I believe that in Korea also very, very popular to implement. Then what we are now providing is how we can maximize the benefit of this VSD. Just to put the VSD is very, very wasting energy. So to maximize it, this is very important. Then we are an automatic control solution provider, so we try to maximize the benefit of the VSD. Okay, in case, this pump, how we can maximize is the one which we have to consider. And then this is the primary pump system, so we have to control the differential pressure in between the supply header and return header. To maximize it, we have to use a VSD to maintain the differential pressure in between the supply and return header. This is a basic concept. So of course, we have to think that we have to avoid the low flow chiller shutdown, meaning that we also need to think that how we can maintain the minimum flow of the chiller, each chiller. This is also one of the control items we have to think. But anyway, this is the one, very simple one. Also, the condenser pump also, sometimes VSD is implemented. So in this case, we also need to maximize the benefit of the VSD, how we can control it. So this is also one of the example. Same as the condenser pump, cooling the fan also, sometimes the VSD have been implemented. I'm in charge of the global business of our companies. So I know the mechanical design tendency of each country. Like a Southeast Asian country, like Singapore, most of the cooling tower have a BSD already. So some have to think that how we can control this. Okay, then this is also one of the control items. What is the best fan speed to maximize the benefit of the entire chiller plant? So we cannot think only the fan energy consumption. We also need to think that the entire system energy efficiency has to be achieved at the best operating point. That is also one of the important points. Then as a result, this is just an example, 14% saving can be expected from this very basic control. The second one is advanced energy saving application. So from here, this is one which we would like to promoting to implement this to the HVAC facilities. Like this is all those are the energy saving application, but we are the, as I say, we are the automatic control solution suppliers. We are not the chiller manufacturer. We are not the HVAC facilities manufacturer. So our target is to improve the entire chiller plant efficiency. Not only chiller itself, not only the pump, not only the fan. Entire chiller plant efficiency has to be improved Because this entire chiller plant, meaning consists from various facilities, like not only chiller itself, but also the primary pump, condenser pump, cooling tower, fan, sometimes secondary pump also. Considering all those facilities, and then we have to find an best operating point. Then from here, I would like to say that this water side efficiency, meaning two water efficiencies. Pump energy consumption is a very simplified pressure multiplied water flow. Very simple. Once we implement the VSD to the pump, water can be reduced very easily. But the point is how we can reduce the pressure. This is the key to maximize the benefit of the VSD. Okay, so this is the our control concept. Very, very difficult to understand, but this is the image of the valve of the AHU, not the chiller side. AHU side. AHU have a control valve. So this is a conventional method. Conventional method, if the load decreases, the valve will react to try to minimize the water flow because the load is decreasing. So in order to maintain the room condition, the valve will start to close to maintain the room condition. But this is very simple explanation, but this is wasting energy actually. This is causing the waste energy. So our target is we try not to close the valve. In order to keep the valve open, how we can do that? We have to reduce the pump discharge pressure as low as possible. Then we can minimize the friction loss by the control valve. As a result, pump energy consumption can be reduced. This is a very basic concept also. But again, in order to achieve this one, we have to think that not only the pump itself, but also we also need to know how AHU is operating. According to the AHU control condition, to get a feedback from the AHU, and then finally we can optimize the pump discharge pressure. This is the entire system and efficiency improvement. This is what we are saying and we are now promoting. So this is the result. This is just example, the 40% pump power consumption can be saved from those applications. Also, this is the next one. It's a variable water temperature, which is a chiller leaving water temperature. I don't know whether in Japan also, in Southeast Asian country also, maybe more than 99%. Chiller leaving water temperature is always constant, regardless of load fluctuation. Even the season also the same. Even in winter season also, chiller leaving water temperature is always 7 degrees or 8 degrees. But do we need to do that? Do we need to maintain a 7 degree at all time? This is the question. And then, so anyway, this variable water temperature control is to change the chiller leaving water temperature according to the load demand together with the condenser water pump consumption. This is what we are now promoting. So once we change the supply water temperature to be higher, meaning that from 7 degrees to 8, 9, 10 degrees, chill water volume will increase. This is a trade-off. So we need to think that supply water temperature become higher, when the chill water pump power consumption will be higher also. So we need to find where the best operating point. So according to this chart, the circle point, this point is the best operating point to minimize the energy consumption of the chillers and pumps. So this is actual data. red line is chiller power consumption, and then the blue line is pump power consumption. And then, according to those data, the best optimum operating point is almost 9 degree. 9 degree living water temperature is the best, according to the data. Of course, we have to think, once we change the 7 degree to 9 degree, the room condition will be changed. So we also need to monitor the room condition at all time. And then once the room condition can be worse than before, we have to set it back to the original. This is also one of the automatic control items we have to think. Anyway, this is one of the energy saving consumption. Energy saving application. In case winter or spring season or autumn season, summer cannot. In summer we cannot do this one, but in the winter or in autumn or in spring season, you might be able to apply this one. Then this is 10%. Around 10% energy saving can be expected. The last one is chiller plant digital twin. It's a quite recent one. This is a kind of simulator. We establish the chiller plant model in the cyber world. Okay, and then what we can do from here is we can do the simulation. Like for example, now I explained that we can change the chiller living water temperature to be higher, but using this chiller plant digital twin, we can roughly estimate how the system will react when we change living water temperature to be higher. This is the objective of this chiller plant digital twin. Okay, estimated energy consumption and simulation, and then of course the simulation can be based on the actual raw fluctuation and temperature information or humidity information. It's also one of just simulation. Okay. So this is a cycle of this activation. Visualization, optimization, evaluation, judgment enhancement, and operation enhancement. This is the one which chiller plant digital twin can be achieved. The first one is just a data visualization. The next optimization and evaluation, we can find a best operating point from those evaluation, simulation. And also, we can know that some invisible fault from those data analysis using this chiller plant digital twin. And then the last one is the operation guidance. What is the best operating condition according to the given condition, or deterioration analysis also can be provided from this digital twin, meaning that like for example 15 years or 20 years past was the chiller has implemented, then maybe the best timing will come very soon to replace the chiller. So this chiller replacement guidance also can be provided from this chiller plant digital twin. Okay, so this is the chiller plant side, and from here, air side is the AHU side. AHU side. You also have energy saving application, and there are 3 steps here: basic air side environment control, advanced control, air side also digital twin. The first one is a very basic one. Nothing to explain because this is just to implement the VAV to the AHU. This is just very, very simple one. Nothing to say. Then the next one is advanced energy saving application. Energy saving application, we have various kind of energy saving applications like all this like AHU control, chiller plant. And then AHU, and we are talking about this AHU. Then I'd like to introduce this VAV optimization. From now, this is conventional VAV. You can see the pressure sensor there. And then maybe this is a standard instrumentation, if I'm not wrong. Can I say so? Most of the case, to measure that static pressure, to maintain that static pressure, the VST is activated, something like this. It's a very standard method. But our one, we don't need the static pressure. Static pressure is not necessary. Okay, and then to get necessary information from each VAB controllers, and then again, the key of the energy saving is how to minimize the static pressure of the fan. To maintain the constant static pressure is wasting energy, because load is always fluctuating. Load is always fluctuating. So, according to the load fluctuation, we better to change the static pressure accordingly. That is the basic concept of the energy saving, the optimization. So from our control method, we don't need the pressure sensors. Then, other than these pressure sensors, we try to get information from each VAB controllers, and then to maximize each VAB damper opening as much as possible. Same as water side. Water side, our target of the control is to maximize the valve opening as much as possible, to minimize the friction loss by the control valve. Air side concept is also the same, to try to maximize the damper opening of each VAB, then to minimize the friction loss by the VAB. That is the basic concept of our control. That's why what I would like to say is, to consider the energy saving, we should not only focus on the one facility, like only fan or only pump. We have to think that related facilities like a VAB or control valve, in case of chiller, we also need to think the cooling towers, condenser pump, chill water pump. All these kind of facilities have to be considered in order to achieve the best operating point. Then this is the one conventional method. Even though the load fluctuation, the fan static pressure is always constant. This is causing the energy losses. And then our control method is to dynamically change that static pressure according to the load fluctuation. So this is the difference. And then we are now providing this to our customer. So this is the result, actual result. 16%, 15 to 16% can be saved from the normal VAB control to advanced VAB control. Then the last one is the set point management. This is also one of the very important. This is very simple, nothing special, but very important actually. For example, this site, set point management is maybe, for example, in Japan, the user of the room can change the room temperature set point from the room sometime. Then normally the temperature set point is always 24 degrees, but because of someone feeling very hot, the temperature set point can be changed to the 18 degree or 20 degree or something like this. This can easily happen, not only in Japan. Southeast Asian countries also the same. Actually, Singapore or Malaysia, Indonesia, such countries, the temperature set point is always 18 degrees. Very cold. Very cold. Then this is causing the very, very big energy wastage actually. So this set point management is very simple but very important. When AHU stop, the set point will be back to the original, which is 24 degrees every day. That is also one of the very important point to minimize the energy wastage. Of course, we have various kind of set point management systems, which is, as I said, this is when only once a day the set point can be changed back to the original, but some of the application is, so it's for example 1 hour later, the temperature set point gradually going back to the original, something like this. This is also one of the way to achieve the energy, to avoid energy wastage. Anyway, this is the application. The last one, the airside digital twin, also same as the Chirapan side. Sorry. airside digital twin also, the concept is almost the same: visualization, simulation, evaluation, and judgment enhancement and operation enhancement. So this is one, all the steps. Then mainly this one is the kind of fault detection. It's the one of the important features of this airside digital twin, especially for the VAV. In case of VAV AG systems, the number of VAV is quite a lot actually. Only one building have 1,000 VAV box or 2,000 VAV box easily, and then very difficult to manage it by the operator, building operators. To find the fault VAV box is also not so easy because of the quantity of the VAV box. So using this one, VAV box also can be easily detect the fault by this application. This is a case study. How we can identify what is the cause of the VAV fault. Also, recommendation of the relation analysis also can be provided. So this is the one we are now providing to our customers, and then I hope this information can be valuable to SADC members. And if you have any question or some how to say unclear point or whatever, don't hesitate to let us know. Thanks for your attention. Thank you.